Welcome to a demonstration of the Demeter framework. This demo will focus on the ability for the Persephone Silverlight client to retrieve data from existing sources and utilize them in a simple workflow. The first thing we need to do is create a WaterOneFlow web service activity. We do this by opening the WaterOneFlow activity group and clicking the WaterOneFlow web service activity button. Once we have our activity, we can double-click on it to open its user interface. It first calls out to a central server hosted by Quasi to retrieve a list of services that they have registered with their system. Then it gathers the variables that exist in all of those services. These act as your search parameters when attempting to retrieve time series data. Once that has finished loading, we can see the map of the whole world. If we want to see the services that are being used, we can go to the settings menu on the bottom left and click the service list option. Here, we see the names of the services, the area they cover, and their URLs. Further information can be seen by clicking the expander on the left. Here, you can see information about the organization itself, the service that they offer, and an abstract about their organization and the service. Once we're done with that, we can close the window here on the right. So now we want to search for some data. We can go into the search parameters sidebar here and search through the variables for what we are looking for. Let's say in this case we want to add water temperature to the variables that we would like to receive. So I begin typing temperature here, and as you can see, it has filtered out all of those variables that do not have what I have typed in the search box. We can scroll down and we see water temperature. So we will go ahead and click plus to add it to our search parameter list down here. Let's add one more, but this time using the variable tree view. We can browse the tree to the temperature subheading and select temperature air and add that to the search list. Also note above that we can change the dates for the data that we wish to search for. We will keep it as is for now, but the option exists. Now that we have our search parameters, we have to determine the area we wish to search. This is done by panning and zooming on the map to the visible area you wish to search. For the purposes of this demo, I will zoom to Lake Tahoe, in particular South Lake Tahoe, which lies on the border between Nevada and California. To find the sites that contain the variables that we wish in the area that we have chosen, I now click the Search for Series Data on the bottom left. This will search the area for the variables selected and return back the series metadata that contains those variables. We can view the series metadata by going to the Settings menu on the bottom left and clicking the Series List option. This window contains the list of sites, their locations, and the variable they contain. Some sites may show up more than once, depending on the variables they collect, as shown in the case of Upper Truckee River at Highway 50, ABV Myers, California. You can view further information by clicking on the expander on the left. As you can see here, there's the service URL that the site was retrieved from, the number of values in total that that site contains, the data type. It could be instantaneous or sporadic or continuous. And once we're done viewing this information, we can go ahead and close this window. Now that we have our series metadata, we can begin downloading the actual data. To do this, we simply click the Download Series Data button. Note that if you wish to download the series metadata or the time series data immediately to your hard disk, before clicking their respective buttons, check the Download Data Straight to Disk box, and it will open a dialog box to download the data straight to your hard drive in a serializable WaterML format. We will do that now to show you an example of this operation. Now, we click the Download Series Data button and begin downloading the data. We're going to save this particular WaterML data as timeseries.xml. During this process, it performs a call to the web services specified in the series metadata. attempting to grab all of the variable values that exist for a site between the dates specified in the search parameters sidebar. If you selected the Download Data Straight to Disk option while it is downloading, it will also be writing. And here it is. As you can see, it is an array of time series, and this is all in WaterML format. But let's get back to the Persephone demonstration. To view the time series data that you've downloaded within the Persephone client, you can look at the Retrieve Values option in the Settings menu at the bottom left. Here, you can see the site where it was recovered from and the variable name. Clicking the expander, you can see series information such as the units that this is in and the value count. As you can see, there are 114 values within this particular time series data at this site. You can see a date and timestamp as well as the actual value of that reading. Once we're done viewing them, we can close this. Now that we've finished that, we can click OK and this will close the window. At this time, we can also connect the series metadata to an activity that will convert the geographical information of each series to KML, a standard used by Google in its applications such as Google Earth and Google Maps. To do this, we create the WaterOneFlow to KML activity, and then we click on the Series Records port for the WaterOneFlow web service activity and the Series Records port for the WaterOneFlow to KML activity. This creates a data channel between those two ports which will be used during runtime. Now, to finish this off, we can save the KML file generated from that activity to an XML file by simply clicking and connecting the KML file port to the data port. We can now go to the runtime and click Start. When the dialog pops up, we click Yes to save the KML file to our computer, and make sure to name it with the extension .kml. In this case, I already happen to have a file named what I wish. So we're going to call it WOFSeriesRecords.kml and save it. The runtime has finished, and so now let's go ahead and open up Google Earth and open that particular file. As we open the file, you can see the sites that were retrieved are now on Google Earth. Eventually, the time series data will be incorporated into the KML, and it will allow you to visualize the time series data. Thank you very much for sitting through the demonstration of the Persephone Silverlight client's ability to retrieve data from the WaterOneFlow web services.